Are we live? Is this thing on? Are we being broadcast on the YouTubes? We would like to be broadcast on the YouTubes. And we wait and we wait and we wait until I get the cue that the show can go. This is TWIS. This Week in Science, episode number 616. So much sibilance. Recorded on Wednesday, April 26th, 2017. Lamb bags for babies? I'm Dr. Kiki, and this is This Week in Science. Tonight, we are going to fill your heads with a drunk crayfish, hungry caterpillars, and lamb bags. But first...
Disclaimer, disclaimer, disclaimer. Don't give up. I understand, believe me, I get it. Somehow nothing makes sense. But so what? So what if not all the puzzle pieces fit the way you want them to? So what if the data sets seem a bit screwy and the timeline's totally topsy-turvy and counterintuitive? So what if the conclusions you've come to conform to no prevailing theory? If you've done things the right way, allowed the right method to motivate the mode of inquiry, followed facts as they were found, recorded results as they were revealed, then chances are you've got it right. And if you're wrong, well, that's okay too. But don't give up, because regardless of how things began, they've at least led you to more This Week in Science. Coming up next.
I've got the kind of mind I can't get enough. I want to learn everything. I want to fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I want to know what's happening. What's happening? What's happening this week in science? What's happening? What's happening? What's happening this week in science?
Good science to you, Kiki and Blair.
And good science to you, Justin, Blair, and everyone out there. Welcome to this week's episode of This Week in Science. Thank you for tuning in once again, or if this is your first time tuning in, welcome. Welcome, 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 one and all. We have a show that's about to begin. All sorts of fun science news. Before we jump into that, though, everyone remember we have about a month to go, a little over a month before we head to Philadelphia. That's right. This Week in Science is going to be in Philly at a science event called the Young Innovators Fair. It's bringing together a whole bunch of people for the youth interested in science. You can find that information at younginnovatorsfair.com.
The youths.
I
hear they are the future.
They are. Let them learn science. On this week's show, I have got stories about, one of the weirdest animals, not tardigrades, naked mole rats.
Yes.
I've got supernovas. Well, one of them. That's 4 of them. We'll talk about that in just a little bit. And some nutritional tea leaves, but I'm not going to make you drink tea. It's more like when you swirl it around and go, oh, bad portents. That's what I've got. Justin, what do you have?
I have Homo hobbit heredity, a hankering for gut microbes, and how running made a better brain.
I don't like running. Maybe I would run more if I knew that it would make my brain healthier. We'll get into that. And Blair, what is in the animal corner?
I have inebriated invertebrates. I have whispering whales. And I have plastic eating caterpillars. I don't know. My alliteration kind of petered out there.
They all sound interesting to me. I am thrilled. All right. This last weekend, it was Earth Day. I was doing the least earthy thing possible on Earth Day. I was hanging out with a bunch of battling robots, which was very fun. There was much smell of smoking rubber and burning batteries and oil and those things. Not very earth friendly, but very fun. There was also a thing going on called the March for Science. Yeah. And if you recall, we talked about it last week, and I said we're going to have a new segment on the show. And every week I will take something from one of our listeners. You have to mail them to me, email me, or tweet or Facebook me, but you have to send them to me somehow.
Yeah.
And I'll give you
Psychic waves of hoping that Kiki says it won't get it there.
Yeah. So, in the spirit of the March for Science and kind of trying to keep that interest and flow going, this segment is called This Weekend, What Has Science Done for You Lately? And this was submitted from listener Mike Hampton. Mike Hampton says, you can have your TV, your computers, your internet, your electricity, etc. How about the most obscure or taken for granted technology? Like the greatest influence of science in the past 20 years has been pay at the pump when buying gas.
Oh, yeah, that's a good one. I love being able to do that.
Just think of all the countless hours that are saved every single day by not having to go into the convenience store to pay for your gas, which should never take more than 20 seconds, and having to inevitably always stand there for 5+ minutes stuck behind 3 other people who are buying cigarettes and scratch off lottery tickets at the register. Yeah. First world problems and all that. It's a basic technology that everyone takes for granted and no one ever thinks about, but no one would want to go back to not having it.
Yeah, like I don't remember the last time I went to a bank to get money out so that I could spend it in the day. That swiping card thing is pretty awesome. Pretty true.
It's very awesome. And his very specific example of the pay at the register, pay not at the register in the convenience store, but pay at the pump.
Yeah, fantastic.
Yes, it is fantastic. Thank you, science, for magnetic strips that allow this information to be passed electron to electron. It's very exciting. And Mike Hampton, thank you for sending in this item for what science has done for us lately for this week on This Week in Science. If you're interested, you can email me at Kirsten@thisweekinscience.com, KIRSTEN @thisweekinscience.com. And I'm just going to start a grab bag and start one a week, you guys. So send them in. Moving on to the Science March recap. Did either of you get involved in the Science March? I know you work on Saturdays, Blair, and Justin, you do very often as well.
Yeah, I was teaching teenagers how to be science educators, so it seemed kind of lame to not do that to March in the March for Science. So I stuck with my plans.
I think you've got a fair assessment there. Yeah, that works. So anyway, thousands of people came out. I don't know exactly how many thousands, but around the world, there were marches around the world. Big cities around the world, small cities. There were scientists, of course, outdoors in Antarctica, because when you're in Antarctica, you're probably a science. And so let's go outside into the ice and snow and march for science with my signs in Antarctica. But the interesting thing that came out of this is that along with many posts of scientists and supporters of science and reasoning, there were, after the fact, being very excited about their experiences or just the fact that the march happened in the first place. There were a lot of people who were trying to criticize it and say, scientists are out there, William Happer, he's a climate change skeptic and a Princeton University physicist. He was interviewed by Fox News, and he focused on climate change. And he says, well, most of them don't know any science. It's sort of a religious belief for them. And then, of course, CNN put Happer against Nye in a televised interview. And Nye said, you're doing a disservice by having one climate change skeptic and not 97 or 98 scientists or engineers who are concerned about climate change. So thanks for that great point, Bill Nye. But the United States definitely was not the only place that this happened. There were scientists in Mexico City, graduate students protesting cuts to the National Council of Science and Technology. There are tensions, however, between the academies of science and medicine and engineering and this National Council of Science and Technology, and which is the country's principal granting agency, like the NSF here and the NIH. So there's a lot of tensions generally. And I think the big fear here, I mean, there is a point to what Happer said about people just being science enthusiasts and not really learning about the science themselves. And so, we don't expect people to understand all the nitty-gritty details about climate science or, whatever, quantum physics. At a certain point, if you're interested and curious about it, you can go on and learn more. It's good to be engaged. It's good to be curious and never to take what you read at face value.
Right. But it is also important to know what the scientific process, when done properly, looks like, how to vet your sources, how to find out who has funded studies, and how to find out if studies have been replicated. Because if you use that information, even without knowing some of the nitty-gritty of the science, you can find out when something is a consensus.
Absolutely. And so let's move into the science.
Yeah.
Science, everybody. Oh, Astro Cook is in the chat room here saying that his friend, a scientist in Riga, Latvia, marched as well with her 8-year-old daughter and others. That's
Oh, and the climate march is this Saturday as well. So it'll be interesting to see what happens.
If people come out again.
Yes.
Keep marching, everybody, right?
Yeah.
Don't stop moving. It's like if you stop moving, your body starts to break down.
You're like a great white shark.
That's right. Our political system starts to break down if we stop moving and just take it for granted, right? Okay, so let's talk about moving and shaking and growing little babies for science.
Fun.
Yeah, well, in this particular case, you might look at this study or what was done here and kind of go, what were they doing? What was going on here? And you might have read a headline about it, but I sensationalized a bit about lamb bags as we
Is that like a purse made out of lamb skin or?
No, it is an artificial womb.
Come again.
Yeah, an artificial womb meant to gestate premature lambs at this point in time. And potentially, if the design goes through many, many more iterations and a lot of testing, maybe it could be used to gestate very premature babies, human babies, outside of the human womb in the future. And so what this study did, and really, trulio, it's a lamb bag. I'm telling you right now, it's a plastic, I don't know what the exact material, but it's a plastic-ish bag. And this bag contained a young lamb. And they were able to attach a blood supply, all sterile blood supply in and out with an oxygenator that worked at just the right pressure for the arteries and capillaries that are involved. They used an amniotic fluid with the right kinds of levels of oxygen and carbon dioxide and nutrients. And they were able to gestate these little baby lambs for at least 4 weeks within the bag, and they grew. And some of the lambs, they grew in size, and they started to fill the bag. They started to grow hair, wool, and they were healthy. And the paper that was published in Nature Communications actually goes through the process of them iterating to improve on their design. So they talk about how they started with a design that wasn't quite right, and they weren't getting quite the right pressures and levels of required nutrients for the lambs in the first experiments, and then they kept iterating, and now they have something that they believe it could support the growth of a lamb much longer than 4 weeks, but that was all that their animal research protocols allowed for this particular study.
And then did they open the bags and these animals were
alive and
running around?
Well, they weren't running around. I mean, they were still very young.
So they were still premature. So they still needed extra care to grow to a point where they could stand up and stuff like that.
Yes, exactly. But basically, the idea here is that by working with a species like the lamb, the sheep, this is a species that physiologically is very similar to humans. And in that similarity, if we can get a lamb fully supported as it develops, it's very possible that we could also develop a system to support human offspring. Mm-hmm. And so we're talking premature babies. And so
this is rescue, not alternative.
This is not an alternative.
Yeah. This is not the Matrix, because that's all I could think about when I was looking at those baby lamb pictures.
Or the clone.
So this isn't like start with a couple of cells, put them, stem cells, throw them into a bag with the right soup, and then let them grow, and suddenly you'll have your baby come, baby in a bag. That's not even close anywhere in the car. I mean, it's just
baby
not
in a bag.
Even.
Instant
not
baby.
Even.
This is premature baby life support.
Right. So this is my question.
And they basically got it to a point, they were able to develop these baby sheep, to a point where their lung function could operate on its own, which in premature infants, cardiovascular and respiratory function are the things that you really need them to be working on their own for a premature infant to be, to not need the hospital support anymore and to be able to go home.
Right. So my question is about the plastic bag, because I would be very interested to know if there would be plans to do some sort of testing on baby lambs that were actually able to grow to maturity, if there would be any concern about the leaching of plastics. Because I think about a warm environment, an environment with lots of liquid and gas exchange happening, growth. I'd be concerned about some sort of plastic leaching.
Yeah, I do not know. I do not know the exact material. This is the bag is made from, and that's an important.
That's a good point too. I mean, it would have to be the right types of plastics. You wouldn't want the PCBs, whatever they are, the estrogen leaking out, the synthetic,
like in the old school now,
estrogens, that sort of thing. Yeah. But I think even with all that, that is the least of your concerns,
right?
At the point where you're trying to rescue a premature.
But baby. What I'm saying is, if you're going to do it right.
Of course, Blair.
So
proof of concept first.
Yeah. Oh no, absolutely. But I'm just mentioning the fact that there's a concern about plastics and extended plastic exposure on any organism.
Yeah, it doesn't say you could probably do a search for biobag, because in the paper, that's what they're calling it. They're calling it the biobag design, and they say it was developed a single-use, completely closed system that minimizes amniotic fluid volumes and can be customized to more closely replicate the size and shape of the uterus. The biobag consists of a polyethylene film that is translucent, sonolucent, and flexible to permit monitoring, scanning, and manipulation of the fetus as necessary.
Interesting.
But I do not know, it doesn't say what the biobag was made of. So that's, polyethylene. Polyethylene. Good enough. Good enough for artificial womb work.
Sure.
Yeah. And then jumping from babies in bags, let's go to supernovas in space. Because supernovas in space, they're super exciting. And what do we know about supernovae?
They're explosive. They make gold.
those are two big things. Yep, big explosions of stars of a particular size. And because they are stars of a particular size exploding, the explosions always happen with the same amount of luminosity, which makes them what we call a standard candle.
1A.
Right. This type 1A supernova enables us to measure the expansion of the universe. And so this is something that many scientists from Hubble onward have been using to measure how quickly our universe is expanding. Where's it going? How fast are different parts of the universe expanding away at different velocities? These are questions that we want to answer. And so one really wonderful discovery just happened. A Swedish team of astronomers, well, they're led by the Swedes, used the NASA European Space Agency Hubble Space Telescope to take pictures of a very special type 1A supernova. And it's a supernova that was lensed by a galaxy in such a way that and we talked last week also about gravitational lensing and how light, the path of light is shifted because of the bending of space. It bends the path of light. And so you think of a supernova, it's just a point source of explosive light that can be used. But in this particular case, the galaxy, and if you can see in this image I'm showing, the galaxy at the center that's lensing the supernova has broken the light path into 4 so that there are actually 4 separate images of the same supernova. These aren't different supernova. It's one supernova, but because of the way the galaxy is bending light, it diffracted it, and there are 4 separate and lensed images of different brightnesses.
That's really cool.
It's very cool because what we know is that if this is from a type 1A supernova, then the amount of light coming from it should be exactly the same, no matter where it's measured within this image, but the amount of light is different because of the shifting of the path of the light. So what this allows researchers to do, and this is like, it's really, we're probably not going to find very many of these kinds of images in space. But what it's going to allow the researchers to do is to, without making assumptions about the expansion of the universe, without making any kind of like, well, we know we're guessing what the cosmological constant is. This is another thing that I think we talked about on the show like a month or two ago. Maybe it was back in January or February. Researchers started to question the cosmological constant and the value that we have for the cosmological constant at this point in time, which is the constant of light and the expansion of the universe. So basically, this is going to allow researchers to test the value of the cosmological constant in a very, very specific way.
As if they didn't know what it was, right? So it's sort of like a control, like,
it's a
we
control.
have a way that should come up with the same number we've been using if we look at it and dissect it. So let's do that. And instead of back engineering the universe with it, we'll just see where, or I guess it is back engineering or backlit, lensing engineering. Yeah, that's cool.
Yeah. So it's like another cool, possibly really accurate way to get at this value without making assumptions, but to actually directly measure it. Yeah. That's pretty neat. We like direct measurements in science because we know what assumptions make us. And I'm not
Assumers.
Assumers. That's right. All right. This is This Week in Science. Justin, what do you got?
Homo floresiensis, aka the hobbits, small humanoid cave creatures found fossilized on the Indonesian island of Flores in 2003. 3.5 feet tall, brains 3 sizes too small, one might think, for the stone tools that they used. And such a story this has been. We've been covering this pretty much the whole time TWIS has been around, right? Or at least I've been part of it. There were competing ideas when this first broke. about what exactly this creature was. A diseased modern human? A result of island dwarfism? Or island dwarfism, not of a modern human, but of a Homo erectus, the direct ancestor of humans? Or maybe, just perhaps, it's an own species. It's entirely own species, right? But it definitely was not aliens. At first, there was the impression that the hobbits had been hanging out on the island as recently as 12,000 years ago, putting them in direct and certain contact with modern humans for thousands of years. That date has since been pushed back 54,000 years ago when they went extinct, which means if there was modern human contact, it was likely brief and disastrous for the hobbit folk, because it's about the same time modern humans were showing up in the area. As more fossils were found at and near the site, the picture became clearer and the mystery deepened. Wrist and shoulder morphologies, all wrong for human. Jaws, not quite right for Homo erectus. Some fossils were found as old as 700,000 years ago. Too old to, well, not, they weren't found that long ago, but they were found to be that old. That's much too old for it to have been human. And these older finds were a bit smaller in stature, which is a very poor fit for island dwarfism scenarios. One by one, hypotheses were put down until finally we were left with, no, still not aliens, but a very good idea of what Homo floresiensis is not. Now, the Australian National University have taken all the ill-fitting puzzle pieces and put them together rather neatly. Study leader Dr. Debbie Argue states, we looked at whether Homo floresiensis could be descended from Homo erectus. We found that if you try to link them on the family tree, you get a very unsupported result. All the tests say it doesn't fit. It's just not a viable theory. The analyses show that on the family tree, Homo floresiensis was likely a sister species of Homo habilis. It means the two shared a common ancestor. Homo habilis, one of the earliest known species, really I think the earliest one that they put the Homo in front of human in Africa is like in a 1.7 million year-ish ago range for when that started. So Homo habilis, so ape-like and primitive, it almost got Plutoed out of Homo for being Australopithecus-ish. That floresiensis could have branched off earlier in the timeline, more than 1.75 million years ago, and also evolved into tool-using hominid, might mean that tool use began Homo habilis, which would be confirming some evidence of meat-rendering tools dating back 1 million years before the time of Homo. This then gives us another set of mysteries to solve, right? Leaving open the possibility that the hobbit evolved in Africa and wandered out, or that the common ancestor of hobbits and Homo habilis itself left Africa and evolved into the hobbit at some point, somewhere, yet undiscovered. With the recent pre-announcement that the recently discovered Homo naledi might be as young as 200,000 years old. This is going to be a story for probably next week or 2 weeks from now. They've announced that they think it's 200 to 300,000 years old, this Homo naledi, but they haven't offered up the paper yet. Mm-hmm. Yeah. That would mean that during the age of modern humans, there would also have been Homo erectus, Neanderthals, Denisovians, naledi, Hobbit floriensis, possibly even, though still needing some further confirmation and finds, the red deer cave people, making at some point during our humanity of modern humans, there would be a total of 7 human populations sharing the planet at one time, all advanced enough to be using tools. Wow.
It's amazing. It really is amazing to think that there were possibly so many separate species or subspecies on the planet, and that they were all using tools, that they were all that smart. But I think I remember there was a study that you reported on like fairly recently, within the last 6 months or so, talking about tool use kind of going back further in time within at least one of these groups.
Australopithecus there's been debate. They had tools. Did they really use it? They found stone tools that look like they were for cleaving meat that were much too old to be Homo habilis, right? And so this is, and the idea now that we have something that was, of the Australopithecus split off that is using spears, right? And in Indonesia, really says perhaps the tool use that did start up much earlier than we believed before, and fits those data sets that are still a little bit controversial about the 3.5 million year old tools that are being found.
Yeah, and Blair's sitting over there going, well, if you look at modern primates and their tool use and all of our studies with birds and other animals that are using tools, this is not surprising.
Yeah. Well, and not to mention what I was thinking about too is that whenever nature and, evolution has found a new adaptation that is somehow advantageous, that has not been used before, a new niche is found essentially, and different species try to take advantage of it, there's this huge adaptive radiation, right? There's a bunch of organisms that show up that are trying to use the same space and use the same adaptation or something similar. And then it gets whittled down to just a few that are really successful. And this happens time and time again. And so this, if anything else, just proves to me more than other things that we've seen that humans and human-like organisms are just like any other branch of the evolutionary tree.
Yeah. And I mean, there is the point to be made as well that if you're not looking for tools because you don't think that tools could have been used, that you think they were too primitive to have had that cognitive capability, then maybe you wouldn't recognize the rocks, the markings, the bones of animals that have been used and adapted to become tools. Maybe they wouldn't necessarily have been recognized at one point.
And also I can't help but bring up the point too, that
and there's erosion.
Whenever any of these groups seem to have at some point encountered the modern human, it meant their end. And I don't know, maybe we weren't cutthroat and violent back then. We are today, but maybe we weren't back then. Maybe we were just disease ridden, and that's why.
We couldn't be. Our jaws were too weak, right? Isn't that the study that the reason we have a strong jaw and a strong hand is for punching?
Yeah, but we can't take a punch. That's the other side of it. Some of these other humans could have really taken a punch much better than we can. So I don't know.
Yeah. But it's so fascinating. We are down to one species that we know of. We've incorporated them. We are the Borg.
What about Bigfoot, though?
Right. But we could be missing, like you've pointed out in the past, this is a lot of morphology involved. What we need is DNA. And we might find, as looking back has been being discovered over and over again, it's not direct lineages, it's the braided stream of things overlapping and recombining and going back out again. While we say that I'm saying that there might have been 7 humans on the planet, there could have been plenty of other hybrids if you count a Denisovian human hybrid. Well, is that another human that could have started off that? And this is how the evolution going back likely was. That's why there's overlapping characteristics. The hominidity is a really strange one. It's got characteristics, some of which are similar kind of to Floresiensis, and a lot of Homo erectus is obviously there too, like in skull. So there's a lot of crossing these DNA streams. So it'd be fascinating and interesting. We've got to keep looking, and we've got to get some DNA to throw into the mix to some of these populations so we can really see what's going on.
Yeah. But I think it's time to see what's going on in Blair's Animal Corner.
She loves our creatures, crab and slaw. Buy a pet, millipede, no pet at all. Wanna hear about animals? She's your girl. Except for giant pandas and squirrels. Then I'm no closer.
What you got, Blair?
I have the solution to our plastic problem.
Yeah.
Yes,
Have a
this is
solution
breaking
already? That was quick.
news.
Solve it.
Wax worms, or as I know them, bird food.
Yeah, candy bars for birds.
Yeah. Turns out they have an interesting trick up their sleeve. They are known in Europe as a pest in beehives because they actually are parasites in bee colonies. They lay their eggs inside hives. So when they're adults, they're wax moths, and then their larvae are wax worms. The wax moths lay their eggs inside beehives, and then the worms hatch inside the beehives and grow on the beeswax. That's why they're called waxworms. A chance discovery by an amateur beekeeper in Europe happened when she was removing these pests from the beehive. She was plucking these little worms off of the honeycombs, throwing them in a plastic shopping bag. A little bit later, she looked down, and there were holes in the plastic bag. Yes. She got in touch with some people from the Institute of, the University of Cambridge's Department of Biochemistry, because she herself was a scientist from the Institute of Biomedicine and Biotechnology of Cantabria, Spain. She got in touch with these guys at University of Cambridge and wanted to help kind of put forward a new study on these waxworms. They put 100 waxworms in a plastic bag from a UK supermarket. This is a lot of the plastic that we find in oceans and just filling our dumps. And holes started to appear after about 40 minutes. And after 12 hours, there was a reduction in plastic mass of about 92 milligrams from one bag. Now, to put that in context, I think a couple years ago, last year, we found a bacteria that biodegrades some plastics, and they ate away at plastic at a rate of 0.13 milligrams a day. And this is 92 milligrams in just 12 hours. So this is a quick degrading of this plastic. And the first thing that I thought was, so they're probably just chewing on it and munching it into teeny tiny pieces and turning it into microplastics, and it's probably bioaccumulating in their bodies. So it's not actually helping anything, right? That's kind of what I assumed. But it turns out that is not what was happening. They think it's a combination of the beeswax, the adaptations they have for eating the beeswax, because beeswax is really kind of stiff and thick and almost like the plastic of nature in a lot of ways. And so they think that there's an enzyme in these worms that helps them break down the beeswax that could be used to break down the plastic. So the wax is a polymer, and so the plastic itself is a polymer, right? And so they looked, they did spectroscopic analysis to see the chemical bonds in the plastic, and they were actually breaking. The chemical bonds in the plastic were breaking. They were actually breaking down this plastic. They transformed the polyethylene plastic into ethylene glycol. And so this wasn't just chewing it into teeny tiny pieces. They were actually breaking apart and degrading the plastic. My favorite thing about this too is one of the ways they made sure that they weren't just biting, it wasn't just a biting motion that was doing this, is that they actually they squished a bunch of wax worms, and then they spread it on plastic, and it still broke it down. So it's some sort of enzyme inside the wax worms.
So, okay, wax worms or waxworm paste.
Yes,
Can
yes.
break-
So they
can break down
smeared
your
this waxworm
plastic
goo
bag.
on the polyethylene bags.
Poor worms.
Got similar results.
Scientists just found a use for us. We're gonna get mass produced on a
Right.
massive scale. And wait, what's that? Oh, and then they're gonna squish us and use us as paste. Okay, hang on.
Right. So to put this in a
That'll be
little
good
bit
about
more context, the polyethylene plastic is about 40% of total plastic produced in Europe, at least, and 38% of plastic is discarded in landfills. And we use about 1 trillion plastic bags worldwide every year still. So there's still a lot of plastic out there. We're still creating a lot of plastic. The hope is to implement this finding into some way to take this enzyme and use it as an actual cleaning solution for oceans, rivers, and the environment. So they're trying to identify the molecular process, isolate the enzyme, and make it some sort of cleaning solution. They're not trying to propagate these parasitic worms, because remember, we're trying to save the bees, so that's probably not a good idea. They're trying to take something from the worms to be able to get rid of the plastic. I do want to say, though, I think it's really important to mention, this does not mean we now have carte blanche to use plastic. This is a great opportunity to clean up the plastic that already exists. We still need to stop making more plastic.
Yes. But we do need to make more worms. So how does it or
Or
at least
enzyme.
Yes, so we don't want more
synthetic
worms because
version of
remember I
enzyme
said these
to-
guys are parasites to bees, and we need bees. We already are stressing out bees on other things. We don't want to further stress out bees.
Oh, we wouldn't
Right.
have
So
like.
we gotta formulate the enzyme.
I'm just thinking we wouldn't be having these wax moths, wax worms to just let them go. They'd probably be in giant industrial worm farms.
Right, but
Yeah.
how do you stop them from every once in a while turning into a moth and getting out of an
You
air
don't.
duct?
You
Right.
don't.
So that is something.
en masse worming their
Screams?
way out. And like
Worming.
the thing that ate plastic, a giant ball of worms came rolling through the city, eating all of the plastic in sight. Oh
Through
no!
a car while they're at it. Yeah. So
Like
this
it.
this could be an opportunity to clean up some of the mess we have made thus far, but we still need to reduce our plastic. But I think this is very exciting because up to this point, we haven't seen a whole lot of options for actually, for real, getting rid of plastic. We've seen ways to break it down into tinier pieces, but not to completely get rid of it. So this is great news. And moving on to drunk invertebrates.
Excuse me?
The other story I brought is a little more lighthearted.
What?
It talks about getting crayfish drunk.
Why? If you're a scientist, let's go get a crayfish drunk and see what happens.
So
Well,
actually,
this is-
I had some crayfish for another experiment in the tank. Then one of the house parties got a little out of hand. So turned out to be an experiment on what happens when you pour a lot of alcohol around the crayfish.
So University of Maryland, and I do believe at some point when we were in Baltimore, I was talking to someone from University of Maryland that works with crayfish. So this is very interesting that another study about crayfish came out of University of Maryland. They were looking at social context in inebriation. Let me explain. Do you get as drunk on the same amount of alcohol if you are a loner versus if you are very popular? Turns out, according to this new study, there may be a difference. So past social experience might shape the neurobehavioral effects of acute alcohol exposure. So scientists from the University of Maryland took crayfish who had previously been housed together, put them in separate tanks, and they put them in tanks of dilute alcohol ranging from 0.01 to 1 moles per liter. And then they filmed the animals. They initially began walking aggressively on stiff, straight legs. So angry drunks, I suppose. Then they started tail flipping as they became more intoxicated. So maybe they got kind of silly and loosey-goosey. And finally, They lost control, rolled over on their backs, just like an incapacitated human.
An extremely incapacitated human. Yeah.
Yes. So the effects took hold much faster at higher concentrations, as we would expect. They got drunker faster when they were given more alcohol. And the intoxicated animals started enthusiastically tail flipping after 20 minutes in the strongest alcohol. But animals that were bathed in the most dilute alcohol took almost 2 hours to feel the effects. So these are all of the social crayfish. However, when they tested the effects of most concentrated alcohol in crayfish that had been in isolation for a whole week prior to their, quote, drinking spree, the animals were less sensitive to the alcohol, taking 28 minutes to become inebriated and begin their tail flipping behavior. So somehow,
Yeah.
their social context, their previous interactions with other crayfish, has changed something in the way they respond to alcohol. To look further, they looked at neurons that control the crayfish's drunken behavior. So they inserted fine silver wires into the sensory nerves, or near the sensory nerves, that excite the lateral giant interneuron, which controls the tail flipping behavior.
The tail flipping, yeah. Basically, you can't do this to drunk college students, but you can do it to crayfish.
There you go.
Yeah.
So they found that the neural circuit was more sensitive in both the isolated and gregarious crayfish when they were inebriated, but the effects of the alcohol became apparent more swiftly in the social crayfish's interneuron.
So let me explain
So
what's
this
happening here,
actually
just for a
affected
second,
them at the neuronal level.
neuronal level. But it's the dropping of inhibition. And when
Mhm.
you're being socially interactive and you've lost your inhibitions, your social interactions are a little, more tail flippy. But if you've been just sort of living alone and your inhibitions are down, what are you gonna walk around the house in the underwear that has the the messed up elastic?
that's kinda like
it's not gonna make a difference.
If you're drinking alone and you have one glass of wine too many, you're probably just going to fall asleep. But if you're drinking with a bunch of friends and you have one glass too many, you're going to get real loud and maybe start dancing.
Hey, let's put some music on around here. This is just
and thus the tail
Fun.
flipping, the human version of tail flipping. Yes.
Yeah, so they actually measured a difference in the effects of alcohol on individual neurons in the isolated and communal crayfish. So they think that this is something that could probably be extrapolated to mammals, but obviously crayfish and mammals, and even furthermore crayfish and humans, are very different. Their neurons are very different, but we also have a lot in common. So the hypothesis moving forward, so now they know social experience can change the sensitivity to acute alcohol in crayfish. The hypothesis is that inebriated people could potentially have different responses to alcohol depending on their prior social experience.
Yeah, and if we take social experience versus isolation to kind of its extreme, what you're doing is if we're talking about and we are talking about neuronal habituation. In a social situation, you become habituated to others in your presence, right? So you're used to that and you're used to the stuff that they're doing around you. You're habituated to others' behaviors. But if you are isolated, you're only aware of your own behaviors. And once you come out of isolation, you might jump at shadows a little bit. So you are going to be more sensitive to social interactions and be paying more attention to what is happening around you from a survival perspective until you become habituated to the idea or the stimulation coming in and realize that it's not going to kill you.
Right. Absolutely. Right? And so where it's fun to joke about drunken crayfish and even drunken college humans, it's important also to mention that the researchers are actually looking at this stuff in the hope that one day they could use crayfish and this experiment to move further on and develop better treatments and preventative measures to support humans suffering from alcohol abuse, which is really the the hardcore reason for studying this kind of stuff.
Yeah, absolutely.
Mhm.
And if we can figure something out in a crayfish, we'll have sober crayfish.
Hooray!
Hooray. That does it for this first half of This Week in Science. We're going to take a quick break and we'll be back in just a couple of moments with more stories. We've got a bunch of naked mole rats running around, and Justin's got gut bacteria. And I think we've got some very quiet whales. We'll be back in just a few moments with more This Week in Science.
Explain the things you heard with more than intuition. The line of reason shows the way to go.
Hey, everybody. I hope you're really enjoying the show and you keep on listening because there's so much more science to come. Thank you so much for listening to the show. We do appreciate you watching or listening, whatever, however you get your twists every week. We're glad you do get your twists. Tell your friends about it, please. Tell your friends about us. And also, if you are in the Philadelphia area, mark your calendars for June 10th and 11th for the Young Innovators Fair. You can find information at younginnovatorsfair.com. And TWIS is going to be there both days of the weekend, talking science and broadcasting. It should be so much fun. Very excited about this opportunity, and we look forward to seeing you there if you are in the area. We also have merchandise that you might enjoy if you're interested in supporting TWIS and also running around with, shirts and other things that have our logo on them. You can head on over to our website, twis.org, where you can find our Zazzle store. If you click on the Zazzle store link, it will take you directly to the page, the store, zazzle.com/thisweekinscience, where all of our TWIS goodies reside. And right now we've got a 15% off code, April showers. Ooh, other ones you can get a 50% off. There's all sorts of discounts happening right now. That's very exciting. 15% off your TWIS tote bag. But do note that the proceeds go to support TWIS, and so you are directly supporting this program by buying and wearing our stuff or putting pillows on your couch if that's what you decide to do. Alternatively, if you don't need any more stuff, some of us are minimalists, I get that, you can always support us through donations. And so if you go straight to our website and click on the donate button, big yellow donate button, makes it super easy. It'll put you through to a PayPal interface that will allow you to donate one time, whatever amount you like. If you're interested in donating in a different way, doing something a little bit crazy, exciting, fun, dare I say, you can join our Patreon community and become a patron. You just click on that Patreon button on the TWIS header. Patreon is how it's spelled, Patreon, and you go there to be able to click on the patron button, become a patron. Click on it and you will be able to create an account and support us and help produce the show that we bring to you week after week after week. You want to keep this show going? Become a patron of the TWIS Science Arts. If you're unable to support us financially to help be a producer in that way, there are many, many other things that are very helpful. And the biggest thing that we need right now is for you to tell people about TWIS. If you're watching on YouTube right now, share the video right now. Right now, share the link, everybody. Are you on Facebook? Right now, share that link. Are you watching right now? Listening right now? Just take a moment while we're taking a moment to talk. Take a moment and share TWIS. It would really be helpful because you know what? We are nothing without you. We're nothing without our audience, and gaining a larger audience will only help us grow and become so much more fun and exciting, right? Fun and exciting science for everyone. We thank you for your ongoing support. We really could not do this without you.
Now due to the juices and pills and the creams, your body's lost toxins, whatever that means. You've stopped eating all of that sinister food. Your dinner tastes awful, so it's gotta be good. And still, you can't believe what a skeptic I am. I can't believe you believe in that sham. We disagree.
And we're back with more of This Week in Science.
Welcome back, everybody. What do you have, Justin?
Oh, am I supposed to be now because it's this part of the show, I bring another story. You are what you eat. Or so the old saying goes. The idea being that what you put into your body is the basis for the building blocks of your health, good or bad. And the statement seems to imply that you are implicit in this decision. Right? Your choice, what you eat. Now, a new saying by neuroscientists, a new study anyways, hinting that food choices may be much more about what is going on in your gut.
Oh man, they're telling me what to eat.
Yep.
That gut bacteria speak to the brain and can control food choices. In the open access journal PLOS Biology, researchers identified 2 species of bacteria that have an impact on a fly's food fancy. Make no mistake, this is microbes giving commands to the brain, and the brain then giving commands to the fly, and the fly doing the thing that it was told to do via the brain from the gut bacteria. Microfloral mind control, if you will. The investigation was led by Carlos Ribeiro and colleagues from Chemp Alemand Center for the Unknown in Lisbon, Portugal, and Monash University, Australia. Experiments conducted using the fruit fly Drosophila melanogaster, a model organism, allowed the scientists to dissect the complex interaction of diet and microbes and its effect on food preference. Okay, so the scientists initially showed that flies, when they were deprived of certain amino acids, showed decreased fertility and increased preference for protein-rich food. The team found that the removal of any single essential amino acid was sufficient for the fly's appetite to increase for this protein-rich food, right? Okay, so it's the amino acids, right? That's what's doing it. Furthermore, the scientists tested the impact on food choices of 5 different species of bacteria that are naturally present in the guts of fruit flies in the wild, which is how many they have. Humans have hundreds and hundreds and hundreds and hundreds. They have 5. Okay. The results of this exceeded the scientists' expectations. They were just playing around. We'll take out a couple of these bacteria, see what happened. 2 specific bacterial species could abolish the increased appetite for protein in flies that were lacking essential amino acids. Oh my goodness. That means
that they weren't getting all the nutrients they needed.
Because it wasn't the amino acids that were triggering this food desire. It was the bacteria recognizing somehow the loss of the amino acid and saying, hey, go eat this, because without them, they didn't know to do it. With the right microbiome, the fruit flies were able to face the unfavorable nutritional situations, says Santos. In the fruit fly, there are 5 main bacterial species. Well, we already covered this. So then the question is, how is it that the bacteria act on the brain to alter appetite? Their first hypothesis was that the bacteria might be providing the flies with the missing essential amino acids themselves.
Because bacteria could do that.
Yeah. So they tested this, and they didn't find that. It was not supported in the experiments. Instead, the gut bacteria, according to Santos, seem to induce some metabolic change that acts directly on the brain and the body, which mimics a state of protein satiety. Study shows satiety. Study shows not only that gut bacteria act on the brain to alter what the fly wanted to eat, but also that they might be doing so through a unknown mechanism.
That,
Unknown mechanisms are cool.
that means more study necessary.
More study needs to be done. But, it's one of those things that I don't know how many times, just even on the show, we've talked about it, or anecdotally, this is why dogs eat cat poop when you take them for a walk. It's because there's an amino acid in there that they can't.
Right.
themselves or whatever.
Why people eat dirt. Right.
Yeah. Like all of these, we have all these examples. We've talked about it before, but now it turns out it may not be. I mean, this is the signaling, perhaps part of the signaling mechanism to the brain that tells it that it's missing the amino acid. But now, how does it do it?
How do the bacteria specifically signal? Well, we've been talking a lot about this gut-brain axis recently, and we have spoken about compounds that are part of the pathway, part of the communication pathway that get in there and stimulate nerves in the gut that then talk to the brain. So it's very possible there is something like that going on. Don't know what compound it might be, though. That's interesting.
And we've talked quite a bit too about how there's whole portions of this animal brain that we humans walk around with that is controlling our activities. That not everything is a conscious choice that we're deciding that we're hungry, because of course it's the brain telling us that we're hungry through a bunch of mechanisms. But the idea that there is something that is informing the brain and that the brain then commands us to eat something. This is it's all part of the same body-mind combination thingy. But it is really weird to think that your gut microbes have that kind of power over you.
That's why we open the refrigerator, even though we know what's inside of it, and we stand there and we stare at it for so long because your bacteria have to figure out what's in there.
I don't know why I picture them all leaping up. Okay,
what's in there? I want to see. I can't see. I can't see.
Move the ketchup. Move the ketchup. What's back there? Ooh, yeah, that's what we want. Yeah. Cheese has got a little mold on it, but leave it on there, please. That's what we want.
Exactly. Oh, so let's move on from the bacteria that tell us what to eat to naked mole rats. Yes. Naked mole rats are really weird, right? They don't get cancer.
Yeah, they're basically invincible. They don't mind acid.
They don't mind acid.
They don't they have because they don't get cancers, they also have pretty decent longevity.
Yeah.
Right. They live for a really long time. Researchers are like, what is going on with the naked mole rat? Yeah. And so recently, researchers are like, let's just give him one more twist. Let's deprive them of oxygen.
Okay.
If you put a mouse into a tank where you can suck out all the air, a mouse will die after 45 seconds, dead. Yeah. Dead. No more
pushing up the daisies.
Yes. No resuscitation. That's not happening. If you stick a naked mole rat into a tank and suck out all the oxygen, they pass out because, there's no oxygen in there. But they can be revived after even 18 minutes without oxygen. Their bodies survive up to 18 minutes with no oxygen. You want to know what they do? They switch their metabolism. Their metabolism switches from a glucose-based to fructose-based metabolism.
So wait, are they active during this period or are they passed out?
No, they pass out. They do pass out. It's not like, we're just walking around like it doesn't matter. But the cellular metabolism, the cellular respiration that occurs, for which you need oxygen, where oxygen is transferred for carbon dioxide, our bodies basically use a glucose metabolism to do that. And mice do that. We do that. Glucose metabolism. If you are in cell biology, you're going to learn the Krebs cycle, and you're going to learn about glucose metabolism. This is like a very basic, advanced high school, college subject. Well, these mole rats, when they are deprived of oxygen, They use fructose instead of glucose.
So this
And
is
so-
interesting. I thought it was going to be a breath holding scenario,
Nope.
like when elephant seals can dive for an hour and not take a breath.
No, their
But
cells.
nope.
Right.
Their
And
cells
and
do
I
that.
thought it was going to be like they could just really go without oxygen for a long time and still keep plucking along, because you figure their little burrowing undergroundy thing, there must be cave-ins occasionally, and then they're like, oh, okay, I have 18 minutes to find another air pocket, you know.
Yeah, so they found high levels of a fructose transporter, GLUT5, GLUT, GLUT5, all throughout the animals' bodies. And the researchers, a co-author, Gary Lewin of the Max Delbruck Center for Molecular Medicine in Germany, said, together this allows the naked mole rat to use fructose as fuel instead of glucose when there's no oxygen. And so now, knowing that we are related to naked mole rats, the researchers are trying to figure out whether or not this is something that could be if there's a metabolic switch that could be used to upregulate these glucose, not glucose, but the GLUT5 fructose transporters that maybe could help people during stroke or heart attack when our bodies and brains are deprived of oxygen. So if there was something that could be injected or some way to allow our bodies to metabolize fructose instead of glucose, then that could go a long way towards reducing harm from those devastating events.
So Kiki,
Yes.
why can the mole rat do this?
I
What
don't
function could it
know.
possibly serve? Because they pass out. Like Justin was saying, they're not finding a new air source during that time.
Yeah.
No, they're not. They're not finding a new air source, but they're not dying. Yeah, it does. I don't know.
So is it possible that if we turn down the oxygen concentration, they'd kind of toggle to half and half?
Possibly. I mean,
Right.
maybe because,
right.
like
That's
Justin said, they're underground and they're burrowing. Maybe because of their metabolism, or because of where they're going, air rises out, and so oxygen maybe escapes, and maybe they do end up in low oxygen pockets every once in a while when they're burrowing. Yeah, maybe it allows them to live in possibly lower oxygen environments.
Yeah, we got to witness it because of an extreme event. But yeah, I think I agree with you, Blair. I think it's probably something that works on a less deprived oxygen, or a low oxygen environment, which allows them perhaps to hopefully to continue to function and do their burrowing and things. And if you're sleeping down there too with a bunch of other mole rats, maybe the oxygen gets used up a little quicker than anticipated sometimes.
Yeah. So, I mean, it's interesting that using fructose, you don't have the steps of glycolysis that require oxygen. So you don't need the oxygen during those periods of time. And oxygen itself is a free radical, right? It causes it is a radical that causes damage to our cells. Maybe this is tied in also somehow with their other health standards that these mole rats enjoy. Yeah. Maybe it could be used to combat aging in humans. I don't know. More fructose for people. I don't know.
Yeah. Better health through a high fructose diet. No, that's not where this goes.
High fructose corn syrup, you say? Done.
No.
No. But what is good for the human body?
What is?
Exercise.
Yeah, we know this. Yeah.
It also turns out, though, that it's good for the brain, and in some ways may even help explain our very evolution as an intelligent species.
Mm-hmm.
All those humans we were talking about earlier ran around in largely the same way on 2 feet. And this is researchers at New Mexico Highlands University. They found that the foot's impact during walking sends pressure waves through the arteries that significantly modify and can increase the supply of blood to the brain. Until recently, the blood supply to the brain, also known as the cerebral blood flow, aka CBF, was thought to be involuntarily regulated by the body and relatively unaffected by changes in the blood pressure caused by exercise or exertion. The research team and others previously found that the foot's impact during running, which is between 4 to 5 G-forces, caused significant impact-related retrograde backflow waves through the arteries that sync with the heart rate and stride rate to dynamically regulate blood circulation to the brain. We kind of run somewhere along the rate of the beats of the heart. It's kind of it's an in sync thing. Our 120 beats per minute heart rate is also about how many steps we're taking by running in that minute. It's an odd sort of a seems to sort of the stride and the heart rate seem to coalesce kind of nicely there. What was sort of interesting here, though, is the new data now strongly suggests that brain blood flow is very dynamic and depends directly on cyclic aortic pressures that interact with retrograde pressure pulses from foot impacts, meaning that running even has more of effect than walking, whereas when they tested bicyclists, for instance, there was no impact on the cerebral blood flow. So it's not just exercise, just pedaling, moving the legs didn't do it. It's the actual impact of feet on the ground. As interesting as that is, this is to me like kind of explains how one of the elements that went into the human intelligence, which we also have tracked, we've talked about this before, the morphology of the base of the skull becoming larger and larger to allow more blood flow to the brain. And if we're bipedally running around this whole time, right, all over from Africa throughout Europe, down into Indonesia, humans running after everything, and this is causing more and more blood to want to be flowed or directed towards the brain as we make these foot impacts over millions of years. It makes sense. Okay, they want more blood coming this way. Make the opening a little bigger. Let more blood flow. This is like sort of a natural progression.
Yeah, I wonder. I mean, it seems very interesting. I mean, running and walking in the foot, the way that the physical pressures of impact would work, even just compared to the muscles moving from just moving the legs. Like if you were lying on your back and moving your legs and not having the impact, it wouldn't be the same. And there is the case of the muscle pump, right? Where our veins don't actively pump blood. They're flexible and they're kind of reservoirs. And we have, our little valves in the veins so that as blood goes up, it doesn't go back down again. And then one reason people pass out when they're standing with their legs locked is because blood pools in their feet and they're not moving their muscles. And so the muscle pump isn't pumping blood back up. So if you're standing, yes, Blair, you and I at our standing desks, it's good to move around so we don't just pass out.
I'm the worst at standing with my knees locked.
But I'm just thinking about the impact, the actual physical impact and the shock wave that would go back up the body. I mean, you feel it in your bones, but we never really think about how that impacts the blood return as well. And so that's a very interesting point to bring up.
Yeah, and more so than just exercise itself, like in the bicycling. It's not just the cardiovascular system is going and therefore, the blood flow is increasing to the brain. It's the actual physical hard impact of feet hitting the ground that seems to be doing it in this. And also, I just want to point out that though I am not standing during the show, the reason I'm not passing out is because I'm doing Kegels throughout the entire the entire episode. Yeah.
Good for you. Oh my goodness. Okay, so moving on from walking and running and what's good for your brain, how about what is just good for us, right? Science is full of these proclamations, well, at least science reporting, full of headlines and proclamations of you can drink coffee now, don't eat steak, do this, don't do that.
Red wine is good, red wine is bad.
Right. And so it's the one nutrition is one of the areas that has, I mean, exercise is one kind of complicated area, but we know mostly if you get moving, that's good for you, right? And with eating is basically good for you, but then we're trying to figure out the rules to how do we make our bodies the most efficient? What works the best for our bodies to keep them healthiest the longest, right? And so this week, there were a bunch of studies that I thought kind of all came together, highlighting problems in reporting science and also in the way that science is actually being done. And so I mentioned at the beginning of the show, kind of like nutritional tea leaves. And I think these kind of are things that we should really be looking at and that we try to bring to the show on occasion to highlight, okay, we love science, but, it's not really well understood all the time, and it's not really done really well all the time. And so this past week, there were several studies and articles that were published. And to start, there was a cohort study that looked for a link or links, which was the problem, between sugar or diet soda drinks and stroke and dementia. And, we've heard bad things about drinking soda. And then there are people who tell us that the chemicals that are used for diet drinks as sugar replacements are, also terrible. But, what is really good or bad for us? What's really going to affect us? And so this study started out great with a really strong cohort of around 5,000 individuals. But then, like, over the course of the study, they just kept breaking them up into these smaller and smaller groups. And so basically reducing their sample size by breaking them up. And then they didn't just they didn't statistically analyze for specific questions. It was as if they were P mining. They're going data mining for a significant P value. And they found a significant P value saying that diet soda increases your risk of stroke and dementia. And that's how it's being reported all over the place, that diet soda is bad for you. Diet soda increases your risk. But the reality is it's a correlation, nothing causative. And this is a study that is, like I said, they're not following proper statistical analysis methods, because every time you do another statistical analysis on the same data set that's basically lined up around the same question, you increase your risk of a false positive. The more tests you do, the larger chance that you're going to get a wrong answer, especially because p-value, people talk about p-value all the time. 0.05% probability, blah, 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 all this stuff, right? 0.05 p-value means that there's a 5% chance that your result is a lie. It's 5%. It's pretty big. And so you want to do statistical analyses in a way to really reduce the possibility of that statistical lie, right? And so I just want to, number one, this study about artificially sweetened drink consumption, it's overselling some of these results, and there are, things need to be looked at a little bit more. And so maybe there's no reason to get rid of your diet drinks just yet. And again, like Blair was bringing up, one study, it was one study, one cohort study, not a meta-analysis, not an analysis of many studies, just one.
Yeah. Haven't we had reports of diet sodas making you gain weight before?
Right. And so, but this is part, and so, yeah. And part of the other, maybe diet sodas make you gain weight, but that's not necessarily a direct cause of dementia, maybe of stroke, but not necessarily of stroke either. And they didn't control for what people were drinking and why. So whether or not they were drinking diet drinks because they were already overweight and unhealthy.
And that's actually where I was going to get to. There's the other side is that, chances are more people who are drinking eating diet anything. And I bet you can find that same value with like light sour cream, right? Like it's probably the same group who's like, I'm probably going to have a heart attack or dementia if I don't watch my diet. So I'm going to get the light and diet version of everything I was doing before I got to this condition.
A second study. A second study was also interesting. This one is about saturated fat, right? We've all been told saturated fat is bad. You should be limiting your fat from animal sources and eating more vegetable fats. You want fats with the linoleic acids. You want the corn oil, canola oil. You want the vegetable fats. You do not want saturated fats, right? Well, there's been a lot of evidence recently that this is really not very true. And there are a couple of things this week that I thought were interesting. This one study brings back data from 60-year-old dusty cardboard boxes that were found in the attic of a scientist pack rat.
Love it.
The researcher did a study that was published that kind of supported his hypothesis. Not really, that he was hypothesizing that vegetable oils were better for you than saturated fats. And things weren't quite... Basically, there's this wonderful article in Scientific American where Sharon Begley writes about this issue, and the scientist, it's very possible that he wasn't getting the result that he wanted. His hypothesis was potentially wrong, and so he took all of the data from his study and put it in his attic. And this happens sometimes when scientists get too attached to their ideas. Scientists get too attached to their ideas and they shelve things. They don't get a result that's worth publishing in their mind. And so all the data disappears. However, the study of a scientist, doctor, now data archaeologist of sorts, he's gone through and looked at all of this data, and basically it supports the idea that saturated fat's just fine, and actually vegetable oil is one of the things that is bad for you. People were dying earlier on the vegetable oil diets than they were on the saturated fat diets. So it's not necessarily that saturated fat is good for you. It's just that it's not bad for you. And vegetable oil might not be good for you. And then this comes as doctors are arguing. They just put an opinion piece in an editorial in the British Medical Journal, arguing that the evidence of this kind of stuff supports a rethinking of our stance on dietary saturated fats, and that meta-analyses and very strong data suggest that what we've been telling everyone for years is really more a result of scientists cherry-picking their data and following a hypothesis that they wanted certain answers for, not actually following the evidence. And then finally, there's an analysis of a few papers by a prominent nutritional psychology researcher. We've reported on his stuff before, things like you will eat less if you choose a smaller plate. If you put fruit in a bowl on the counter instead of candy, that'll lead you to eating more fruit and less candy, changing your diet. Anyway, there have been a few inconsistencies that might actually lead to a deeper review of some 40-odd papers that have been cited over 3,000 times. That basically could tear apart the field of research he works in and his entire body of work. And it was all sparked by a blog post that he made on his blog, trying to get grad students just to inspire them to look for opportunities. But instead, in the process, he revealed questionable research practices.
Oh, no.
Yeah, you know how I mentioned cherry picking and data mining earlier? Well, people looked at his blog post and went, really, that's how you do your science? Because that's not right. And so they went back, and the researcher wouldn't release his data to them at the time because it was not it was not anonymized, and so subjects' information would be too available. So at the time, he did not give it up. He has since made it available to people. But the researchers are using new statistical tools that allow them to use the statistics and results of the statistical analyses in various papers just to kind of check for inconsistencies. And they have found, of the papers that they found that they looked at, significant inconsistencies, and they've looked and they've published on that. It's not peer-reviewed study yet. It's published on PeerJ, and there is several papers that they're currently looking at that this guy, basically things are weird, and this guy is now under scrutiny. But the question comes up as to, the question came up as to whether or not this particular researcher, whether he's actually naive 20 years into his career about how to actually do proper statistical analyses, how to actually look at your data for doing statistical tests. And this is a big question. Are grad students being taught enough statistics in grad school?
Probably not. I mean, doctors, there's a whole thing about like the false positive, right?
Mm-hmm.
Where somebody says, you have this disease, and he's like, well, what's the false positives? Well, this is only 1 out of 100 are false positives. So it's 99% true, right? Well, wait a sec. So what you're telling me is that if everybody took this test, 1% would show a false positive. Yes. Well, how many people have this actual disease? Oh, it's 1 in 1,000. Okay. So if 1,000 people took this, 100 of them would show that they had the disease. Well, actually, only 1 of them had it. So really, you're telling me there's a 10% chance that I have this disease? Because that's what the 1% false positive would actually mean in that scenario. Statistics is mind-bogglingly confusing if you don't have a firm grasp of them. But I imagine this is what something like peer review is for.
Actually, and this is a great point to bring up. This is not what peer review is for. I mean, peer reviewers can, on the surface, go check and, okay, your p-values, things line up as significant, and kind of say, okay, you seem to be doing appropriate tests for this. But many peer reviewers they have limited time, and they're not given all the data to do an actual reanalysis of the data for the paper. They're just reading the paper to make sure everything makes sense.
So I've been wondering for a long time about blinding data analysis. So instead of blinding to who has the variable and all this kind of stuff that then later you can look for what you were hoping to find, if you kind of just sent your data off to an unknown person and they ran the statistics on your data, they would be unbiased. And they would be able to send you back kind of this unbiased statistical analysis, right? I've wondered about that for a long time. If this is something that we should be outsourcing to check on ourselves as scientists.
Yeah. I mean, there's a point now. I mean, looking at the where publishing is going and how publishing is changing, there are lots of questions coming up. People want to know that the science is good, and they want to know that it's not going to be retracted. The researchers don't want their stuff to be retracted, right? And so, yes, maybe if we had external statistical advisors, but that's going to take more money, right? Where's the money going to come from? Maybe instead of paying the journals for all the overhead of the publishing costs that we used to pay them. Right now it's $35 for a non-subscriber to a journal to download a paper, right? Maybe that $35, instead of paying for just access to that paper, which no, like only people at the journal were paid for, and it was a grant for the research originally. Maybe that should pay for the statistics. Like maybe there needs to be something else built into the process, because this is turning into a big issue. It's probably always been an issue as we've gone into the institutionalization of science and the drive to publish or perish, and pushing graduate students through. There are many very skilled statisticians among the grad students and the PhD holders of the world. But it is something that it needs to be standardized. There needs to be something.
Although
on.
to be fair to this particular individual, the two fields that we know of that have the most trouble with this are nutrition and psychology. And what he was kind of delving into was a combination of the two. Like this is like, this is not the two groups of dynamic science that you are going to get your best statistical models from in your education at this point, because you're dealing with so many unknowns going in that for the most part, all you have is correlatives of what those two sciences are largely having to base things on for most of the studying that they do, for most of the results that they come up with. I mean, mechanisms are just now in the nutritional side becoming available to us, are starting to emerge. We've had a century of nutritional science that didn't understand the mechanisms for a lot of this. So it's we can in retrospect, we can just think of this as the early stages of nutritional science. Like this is the foundation, this is the beginning, and we can kind of forgive all the mistakes.
Psychology and so many
psychology,
others.
we may never get to attain anything out of the beginning stages. We may never get beyond that.
Well, we have those drunk crayfish, though. I think
we
that's
do
helpful.
have a drunk crayfish. Yeah, going back to the article the researchers publishing in the British Medical Journal earlier this week about how we need to rethink, and what they say, quote, urgently requires a paradigm shift on treatment of coronary artery disease, and our conceptual model of dietary saturated fat clogging a pipe is just plain wrong. And one thing that really stuck with me as I was reading through the article, and if you go to the actual article in the British Medical Journal, that's linked to the article that I'll put in the show notes at twis.org, they say the inflammatory processes that contribute to cholesterol deposition within the artery wall and subsequent plaque formation, atherosclerosis, more closely resembles a pimple. And so they're actually equating these plaques inside of your arteries with pimples, and they say when plaques rupture, analogous to a pimple bursting, coronary thrombosis and myocardial infarction can occur within minutes. So how do you reduce your pimples in your arteries? How do you reduce your artery pimples?
Yep.
I'm never going to think of them
Yucky.
as plaques again. I'm going to go to my doctor and talk to her about my artery pimples.
Your artery acne?
My artery acne. That's right.
Acne?
Artacnery. All right. So I have one more story and I'm done for the night.
Oh, wait, is this not the after show?
No, this is the end of the show, man.
Oh, we're not even there yet.
We're almost there.
Holy smokes.
We're almost there. Let us get there. Exciting news. For the first time in the United States, scientists and physicians at the University of California, San Diego School of Medicine, along with researchers from the U.S. Navy Medical Research Center, Biological Defense Research Directorate, Texas A&M University, and a San Diego-based biotech, among other organizations, have successfully treated someone of a multidrug-resistant bacterial infection. This guy was going to die. There was nothing that could treat his bacterial infection except they used bacteriophages, viruses that target and consume specific strains of bacteria. And they didn't do just a very simple, we'll just give them this phage and that'll fit it. This is like the ultimate in personalized weapon, because they had to determine exactly which bacteria were causing the problem in the first place, find the phages among the library of bacteriophages that we know of, and then find out if anybody had them and were producing them. Hence, here comes the Navy. And they added a bacteriophage to this multidrug-resistant strain of Acinetobacter baumannii, which is a very deadly, very often deadly pathogen. And eventually, he started. This guy was in a coma for like 2 months. They gave him the bacteriophage, and within days, he came out of his coma and started recovering. However, then the bacteria evolved and adapted to the bacteriophage, and he started getting worse. And so then they had to find new phages. And so basically they dealt with a phage cocktail and completely cured him. No more infection. He's totally, he was physically ruined by the infection, and it's a long recovery from that. But this is the first report of a successful treatment, not using antibiotics, but actually the viruses were using nature to combat bacteria. The viruses that destroy bacteria, it worked.
Wow. So this guy got his life back from this.
Yes.
He was down and out. He was done.
He was going to die.
That's crazy. Mm-hmm. That's now, if only we could get phages. Knock out HIV, right?
Exactly. And one of the interesting, at the end of this article that I was reading, which is so interesting, we found that there are thousands of varieties of phage that we know of, and they've each evolved to infect only one type or a few types of bacteria, and they can't replicate themselves, but they have to use the bacteria, the reproductive mechanisms of the bacteria to reproduce. Phages cause 1 trillion successful infections per second and destroy up to 40% of all bacterial cells in the ocean every day.
That's bonkers. So this is my question then. The phage is so good at what it does that it kills the bacteria that it needs to survive, essentially. And so in your body, if I had one of these really terrible infections and I was injected with this bacteriophage, it would kill the infection and then just exit with it. Because there would be
left even.
Yeah, there would be nothing left for them to infect, right? So they're just too good at what they do. So I guess in the ocean is so vast, they don't run out ammo, as it were. Yeah. But in our bodies, we're enclosed, and we're enough of a closed system that they just run.
They run themselves out.
Huh.
Yeah.
This is, and I've talked about this before too, right? We've talked about this has come up on the show a few times.
We've talked about the possibility of it, and we've talked about the possibility of it, and but this is the first time in the United States that it has been used.
I'm just glad they've been listening to the show.
Exactly. I'm glad people listen to the show. They find out about the things they can do.
That's a good idea. We should try that. We should use the viruses in this way.
Yeah. Tell me about whispering whales.
I want to tell you guys about whales. No, we didn't.
Oh, no, we never talked about it.
Where have you been?
I've been
Justin's been on another timeline, you guys. So whispering whales. I might a whale whisper. Whales, as some of the largest organisms on the planet, are pretty loud.
That's the worst call.
Oh, that's great.
It's either it might be a hound dog also.
That's hound doggy. I'm a little somewhere in between.
So humpback whales, they are very, 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 very loud. And the recent study from Aarhus University, from ecologists from Denmark and Australia, used temporary tags, suction tags, on humpback mothers and their calves in the Gulf off of Western Australia to find more about their communication with each other, the mothers and the calves. And they found that these calves whisper to their mothers. They whisper. So they had the tags on them for 48 hours, and then they would detach and float to the surface. And they found that mothers and calves spent a significant amount of time together, nursing, resting. And they found that newborn humpbacks communicate with their mothers using grunts and squeaks. Very different from the normal calls as demonstrated earlier. They occurred while they were swimming, suggesting that it helped keep them together in the murky waters of the Gulf. And they also found a lot of rubbing sounds they described as two balloons being rubbed together, which they think was the calf nudging its mother when they wanted to nurse.
Oh.
And then they also they speculate that the quiet communication, the whale whispers, were reducing the risk of being overheard by killer whales nearby, by orcas, which hunt humpback calves in the Gulf. And they also avoid attracting male humpbacks who still want to mate with nursing females. So
that makes sense.
it's a double win from the whispers. Don't let your father hear you. Also, there's dangerous orcas around. So there you go. Humpback whale whisper.
We see this in a lot outside of humans. I don't know how we survived in the wild, because babies are anything but quiet and whispery. They're squealy and loud. But baby, I guess deer in general aren't very loud creatures. But
No.
the mother deer will eat the feces of their young to cover up their scent, to hide their presence. And so good on the whales for whispering and trying to lay low.
Yep.
I wonder how much noise pollution in the oceans is affecting.
Tremendously, I would think.
Great
Especially from a
question.
whispering whale, because then they have to get louder and talk over, and then the orca's like, "Oh, gotcha, thank you."
Yeah, or maybe if they're whispering, they don't hear each other, and the mother doesn't know what the baby needs, or maybe the mother and the child get separated because they're not talking to each other loudly enough.
Yeah, absolutely. So that actually, thank you for reminding me, was the second part of the study, was considering the sound of ships nearby. So I think that's the next step that they plan, is to kind of explore that a little bit more, how the sound pollution of shipping lanes and nearby ships could affect this mother-calf communication. Yeah.
Babies.
Whispering whales.
Whispering to the whispering to the baby
Whispering
whales.
whales.
Yeah. I've got an email. Last week, Justin, you were talking about marijuana, and there was commentary on the difference between marijuana and hemp. And Sarah Folds wrote in to say there is a major difference between hemp plants used for fiber and marijuana used for THC. Marijuana plants make very poor fiber plants, and hemp does not have THC in usable quantities. Growing strategies are also very different. In marijuana, you want to keep all the leafy female plants. In hemp, the tallest plants give the best fiber, because the vast fiber is what holds the plant up, and you want long, straight fibers.
And I think that was meant to be tallest male plants.
Tallest male plants, yes. Yeah. Thank you very much. And she says she does spinning demonstrations at a folk art festival in Seattle, Washington. And she gets tons of questions all the time. And she gave us a great link if you want information about marijuana versus hemp. And we've got a link that I can share in the chat room, or I've got a link I can share. Ta-da! And man, did we do it, you guys? Are you done?
I think we have completed yet another episode.
We have. And so it's time for me to thank our Patreon sponsors. Thank you to Chris Clark, Paul Disney, G. Burton Lattimore, John Ratnaswamy, Richard Onimus, Byron Lee, E.O., Kevin Parachan, Andy Groh, Keith Corsell, Jake Jones, Brian Hedrick, John Gridley, Stephen Bickle, Kevin Railsback, Gerald Sorrells, Ulysses Adkins, Derek Nickel, Dave Friedel, James Randall, Eric Schwab, Bob Calder, Mark Mazzaros, Ed Dyer, Trainer 84, Layla Marshall Clark, Charlene Henry, Larry Garcia, Randy Mazuka, Tony Steele, Gerald Yonyago, Steve DeBell, Greg Guthman, Brian Staub, Patrick Cohn, XV, Daryl Lambert, Harun Sarang, Alex Wilson, Jason Schneiderman, Dave Neighbor, Jason Dozier, Matthew Litwin, Eric Knapp, Jason Roberts, Richard Porter, Rodney, David Wiley, Robert Aston, Todd Northcutt, Arlene Moss, Aurora Lee, Bill Kersey, Ben Rothig, Darwin Hannon, Rudy Garcia, Felix Alvarez, Cosmic Jispy, Brian Hone, Orly Radio, Brian Condren, Mark, Nathan Greco, Hexator, Mitch Neves, Flying Out, John Crocker, Christopher Dreyer, Artyom Shuwata, Dave Wilkinson, Steve Mashinsky, Rick Ramos, Gary Swinsberg, Phil Nadeau, Braxton Howard, Sal Good Sam, Matt Sutter, Emma Grenier, Philip Shane, James Thompson, Kurt Larson, Stefan Insom, Honey Moss, Mountain Sloth, Jim Drapeau, John Maloney, Jason Olds, James Paul West, Alec Doty, Aluma Lama, Joe Wheeler, Dougal Campbell, Craig Porter, Adam Mishkan, Aaron Luthen, Marguerite, David Simmerly, Tyler Harrison, and Columbo Ahmed. Thank you for all your support on Patreon. And if you are interested in supporting us, you can find information at patreon.com/thisweekinscience. Thank you to all of our new sponsors, patrons especially, and our long-term patrons. Goodness me, you guys are wonderful. Remember that you can also help us out simply by telling your friends about TWIS. And on next week's show, it's going to be May.
Yes.
May
Already?
the 4th be with you next Wednesday.
Wow.
Is that it? No.
It's
We're one day
it's
off.
The 3rd.
It's the 3rd. I was hoping. I was trying for it. Yeah. May the 3rd be with you. But May the 4th is coming. We'll be back here next week. We'll be back in May. Broadcasting live online at 8 p.m. Pacific time on twis.org/live. You can watch and join our chat room. Hey, chat room. Hope you're having fun in there. Don't worry if you can't make it, though. You can watch our show at other times. Past episodes are available at twis.org/YouTube, or you can listen at just twis.org.
Yeah, thank you for enjoying the show. TWIS is available as a podcast. Just Google This Week in Science in your iTunes directory, or if you have a mobile type device, you can look up TWIS, the number 4, Droid app in the Android marketplace, or simply This Week in Science in anything Apple marketplacey.
For more information on anything you've heard here today, show notes will be available on our website. That's at www.twis.org, where you can also make comments and start conversations with the hosts and other listeners.
Or you can contact us directly. Email Kirsten at thisweekinscience.com, Justin at twisminion@gmail.com, or Blair at blairbaz@twis.org. Just be sure to put TWIS, TWIS, somewhere in the subject line, or your email will be spam filtered into oblivion. You can also hit us up on the Twitter, where we are at TWIS Science, at Dr. Kiki, at Jacksonfly, and at Blair's Menagerie. We love your feedback. If there's a topic you would like us to cover or address, a suggestion, an interview, a haiku that came to you tonight, please let us know.
We will be back here next week, and we hope you'll join us again for more great science news.
And if you learned anything from the show, please remember,
It's all in your head.
This Week in Science. This Week in Science. This Week in Science. This Week in Science, it's the end of the world. So I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice. Show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand. And all it'll cost you is a couple of grand. 'Cause this week's science is coming your way. So everybody listen to what I say. I use the scientific method for all that it's worth. And I'll broadcast my opinion all over the earth. 'Cause it's This Week in Science. science. This week in science. 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 This week in science. This week in science. This week in science. 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 I've got one disclaimer, and it shouldn't be news. That what I say may not represent your views, but I've done the calculations and I've got a plan. If you listen to the science, you may just get understand that we're not trying to threaten your philosophy. We're just trying to save the world from jeopardy. Jeopardy. And this week in science is coming your way. So everybody listen to everything we say. And if you use our method instead of rolling a die, we may rid the world of toxoplasma gondii. Cause it's this week in science. This week in science. This week in science. 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 This week in science. This week in science. This week in science. 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 I've got a laundry list of items I want to address. From stopping global hunger to dredging Loch Ness. I'm trying to promote more rational thought, and I'll try to answer any question you've got. But how can I ever see the changes I seek when I can only set up shop 1 hour a week? This week in science is coming your way. You better just listen to what we say. And if you've learned anything from the words that we've said, then please just remember it's all in your head. Cause it's this week in science. This week in science. This week in science. 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 This week in science. This week in science. This week in science. 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 This week in 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 science.
Now we're at the after show. Now we're at the after show. You know what I'm trying to figure out? I just went, like the Android marketplace is basically Google Play, right?
Mm-hmm.
Uh-huh. And is TWIS for Droid even in there anymore?
Good question.
It used to be. Is it even in there? Or like, go there, everybody. I don't even know if it's there. I don't think it is. Oh, Dale Poco. Son finished his last final exam of first semester of college. Oh, those are some good grades. 3 A pluses and an A minus. That's amazing. That is amazing. I did not do as well the first. We were on semesters. We were on quarters. But I did not do as well.
Oh boy.
Maybe we'll just search Google Play. How do you find? How do you find podcasts in Google Play? I don't even know how to find that. Google, why are you not helping me? No. Oh, and an A. You're just putting a hash there. It's just an A, not a minus. Sorry. Yeah, you're just putting a separator in there. I got it. Is it in music? Is it in books? Newsstand? Where do you find podcasts? Categories. Well, you find things in Google. I'm gonna just search for podcasts. Do you guys know things
About Android marketplaces? Definitely not.
Oh yeah. I don't do much in the I should pay more attention. I should pay more attention. Podcasts for Android. Yeah. Ed from Connecticut. Only 3 more years and you have enough money to eat again. Yeah, exactly. Oh, it's just an app. I see your answer, Hot Rod. Okay. Android Central? Is that it? No. Apps. I found it once. Oh, Fado wants to know if we're loving Bill Nye's Netflix shows. I haven't watched it yet, actually.
I haven't watched it yet either.
Yeah. I don't know. I've read some interesting stuff about it, and I probably shouldn't have read anything before I actually saw it. I know a bunch of people who are involved in the show, and I'm sure it's fabulous. But I've also read some, doing science. That's great. Getting conversations about stuff out there. I love that.
Mhm.
But I've also heard that he's been like really pushing the skeptic perspective, which is not sometimes not using the best communication practices to get ideas across. So they're pandering to who they think is their audience and not communicating outside the bubble.
That's pretty much exactly what I heard. I was at a climate change communication workshop today. And yeah, it was a similar conversation I was hearing. Was the science experiments were amazing, and a lot of the educators in the room couldn't wait to adapt them to their own programs and all this kind of stuff. But they were kind of worried that he might have been kind of shouty at people who might not be convinced.
You're not convinced. I'm going to shout at you. Those aren't the people you want to shout at. And we've had that conversation over and over again. It's like there might be some people who were interested in watching his show because they like science and they remember Bill Nye from, Bill Nye the Science Guy from years ago. But then they watch the show and get shouted at and they go, I'm not interested in watching this anymore.
Yeah. So it's about kind of finding the balance between engaging the people who are excited to talk about it and making sure that we're not alienating people who are open to a discourse.
Yeah.
Right? Yeah, absolutely. I heard someone say today, we had a linguist there, and she was saying, we want conversation, not crisis.
Yeah.
I was like,
I think so.
Spoken like a true linguist. So I liked those words. I thought.
Yeah, let's see. So we have Ed from Connecticut. I am so looking forward to the Albert Einstein show. The new it's Nat Geo who's putting out a show called Genius. And the first one's on Albert Einstein, and it just sounds so good. I think that's going to be amazing. Identity 4 says his honest review of the Bill Nye show. Didn't learn any new science from it. It's because you watch TWIS. You're a smart guy, Identity 4. The messages can be pretty heavy-handed, but it was an interesting variety show format. Yeah. My wish is that the panels were longer and more in-depth. I think that's the problem is you want the longer, more in-depth conversations, but they're limited time. They're giving themselves limited time because it's TV, and then you don't get the messages out. You don't get the conversation, and you don't get the depth. And Fada loves it. The cartoon using flavors of ice cream to discuss human sexuality on a spectrum is hilarious. Okay, well, that sounds awesome. I'd love to see that. That sounds really funny. Ha ha ha. And the show gave identity for an earworm. Oh, Brandon, there you are. Android, the podcasts are in Google Play Music app. Thank you. TWIS is listed there. Every once in a while, I find it good to go check and see.
You mean you're not subscribed to TWIS via your Android device?
No, I listen to it all the time. I listen to it like 3 times every week. So yeah, I'm not subscribed to my own podcast. Okay.
That's funny. Well, but then again, like, do you ever listen to the show?
When I edit it.
Mm-hmm.
Oh.
Yeah, so you don't need a subscription.
I never listen to the show. I have a subscription.
You listen to the show on
No.
TWIS, I thought.
Oh yeah, no. That's right. Every Monday morning I do hear snippets, right? I wake up to the show. In fact, it's on alarm clock. That's right. So I hear the intro, but then I've got to like get up and leave the house immediately.
Did you hear my plugs that I did?
No, I didn't. Actually, our show didn't run.
No, he said he ran it.
Then if they ran it really late, or in a different time slot. Because I believe it was one of the other public affairs show hosts that was talking about their show during it. Now they might have at some, but again, I only hear the very beginnings usually, and then I'm off and running about and.
Yeah, maybe they played different people at different times so that.
Which is no, that would be weird.
That's not how they normally do it, right? Yeah. So it was kind of weird, but I didn't listen to the whole hour. I only got the very beginning of it this week. Although it is sometimes fun. I'll with my daughter in the car. On Monday mornings, sometimes she'll be like, "That's you, Papa. You're in the radio." I'm like, "Yeah, get me out of there. Get me out." And then we struggle with the buttons, trying to find a way to get Papa out of this.
Yeah, someday I need to drive up to Davis on a Monday just to hear it. Make it real.
Yeah. Actually, I do need to go by there though at some point and see the book collection that's developed.
Oh yeah.
I think they still send all the books there. I don't know how to redirect this.
I'm getting them mailed to me.
Oh, are you? Are they really getting mailed to you? Oh, perfect.
Well, they're piling up, and then I get Lawrence, who runs public affairs, to mail them to me, and I pay him for the mailing.
Oh, that's very cool.
And so, yeah, it's good. And we've got some really interesting books right now that I am excited. I should bring. They're downstairs and very heavy. Do you want me to go get them?
No, I mean,
I'll go get them.
Oh yeah.
Go get them because I want to bring them up here anyway. I'll be right back.
It's the way you said that they're very heavy. It made me think. She said that they were very heavy. It was sort of like an out. Like, I can go get the books. They're very heavy. I'd have to lug them all the way from the downstairs. But if that's what you want, for you, I would do it.
Really want?
No, really. No, it's fine. You don't need to do anything. So that was a fun show that we just did. Let me see what the chat room is chattering on about. That was a fun show. I think that I think that finally kind of putting to bed the Homo floresiensis thing. Floresiensis. I always say it wrong. I always say floresiensis, but there's no N in it.
It's floriensis. It's not.
No, it's floresiensis. I always say Florentiensis.
I got him.
Whatever. Oh my goodness.
Ah!
Yeah.
You're running a library.
Well, since we stopped doing TWIS at the station, KDVS, I don't have as good a current science book collection. These things used to just every week we'd go down there and there was a stack of books to go home with.
Yeah, which is great.
I still have a bunch
So-
that I am excited to read that I haven't gotten to.
Yeah, it doesn't hurt that I, don't read anymore anyway.
Is this guy decent? This one's fine, maybe. There's some. So we have a couple of books that I've read. We've got a new agey science woo woo.
Uh-huh.
Oh, look, you're trying to write about nature and physics, and you're a former vascular surgeon, and your daughter graduated with honors. That's nice.
Good.
And
Well, hey,
then, and
now,
then there's
to
another
be
one.
fair,
that-
a lot of the books we got were kind of
Yeah.
not.
This one
really
written by a cosmologist, planetary healer,
Oh.
and futurist.
They don't listen to the show, clearly.
Oh, yeah. I don't know about this one. This one might be good. We'll find out. It's Cambridge University Press. Modern Prometheus, editing the human genome with CRISPR-Cas9.
Ooh, I like that.
We have some good stories there. Let's see. Deviate by Bo Lotto. This is about perception and the foundation of human experience.
Uh-huh.
That would be interesting, maybe.
Yeah.
Or it could be horrible. It could be. I don't know. I want to read like a little bit of that book to find out.
I have another copy of Citizen Science. We're going to have to do a giveaway or something.
Yeah.
The Family Gene, a mission to turn my deadly inheritance into a hopeful future.
What?
Yeah, so it's a woman and her story of working out the genetics of her disease.
Yeah. So that's interesting too. That's that's gonna be a fascinating read. Well, I won't read it. But
It'd be a very fascinating read, but to talk to her about her story, right?
to talk to her would be fascinating because this is like one of these. This is one of the, I don't know, drawbacks, side effects, things that comes with this modern age of understanding the genetic inheritability of diseases. When you bring somebody into the world, knowing that there's a really great chance that they're going to be inheriting diseases that you've suffered with, or your parents have suffered with, or
And burp. Yes.
yeah.
There you are. You blurped for a second.
Was I blurping? I'm so sorry.
Blurped.
Excuse me.
This one's
Digitally
the Glass Universe, how the ladies of Harvard Observatory took the measure of the stars.
blurped.
Yeah, so this is probably in the vein of the story Hidden Figures, but
Right.
female human computers.
Cool.
Yeah. Let's see. We'll get some here that you're going to be. This one, I don't know. The finest traditions of my calling. One physician's search for the renewal of medicine. Yeah, I don't know about that.
No
one.
idea where that's going.
This one is called Originals. How nonconformists move the world.
Ooh, I like that.
Yeah, about having new ideas, kind of being on the edge of things. Original thinkers. Yeah. Grant shows that original thinkers are surprisingly similar to the rest of us. They procrastinate, they grapple with doubt and fear, they have bad ideas. What sets them apart is they choose to act anyway.
Yeah. Somewhat the
Zoo.
The Zoo.
There you go. Blair's book.
The wild and wonderful tale of the founding of the London Zoo.
Ooh, there's
Blair's
some
book.
interesting stuff about that.
Blair's book.
Yeah. It might be really good.
That
This
was Blair.
Paul Offit, who has he works on he's often criticized for his work in promoting vaccination, but he has written a book called Pandora's Lab: 7 Stories of Science Gone Wrong.
Oh,
I think could be very fun.
yeah, that's very fun.
And then this one. Bill Schutt is at it again.
Yes.
Cannibalism.
Oh, I absolutely want to read that.
Yeah. And then I don't have The book, what I already have for May 24th, I have scheduled an interview with, let me see if I can find where he went. What was his name earlier? I made an point, I made a thing. I made a thing. There it is. The Evolution of Beauty. The author Richard Prum has a book called The Evolution of Beauty, How Darwin's Forgotten Theory of Mate Choice Shapes the Animal World and Us. I think we've all had enough conversations about this stuff, about, you know, the choosy female and all that kind of stuff. It might be really interesting. Yeah. His new book offers a major reimagining of how evolutionary forces work, revealing how mating preferences, what Darwin termed the taste for the beautiful, create an extraordinary range of ornamentation in the animal world. I think it'll be fun.
Yeah, absolutely.
Yeah. Sexual selection and mate selection. And so that's one that we have.
Oh yeah, I never
already
talk about that on the show, so I don't know if that'd be
That's not come up.
relevant.
It never comes up ever.
No.
Yeah. Oh my gosh.
I have a feeling when day comes, and it will, when Blair is no longer single, or as single, or when she's
Not
married
as
with children, or whatever.
right.
I don't know what your
Whatever
situation is. I
happens
don't care.
next.
But all of a sudden, those stories go away completely. It never comes up again.
No.
It's just that because it's on the forefront of her thought. This is why.
No. Are you kidding? That stuff's going to be intertwined into my vows.
Okay.
Not to mention every step of the courtship. I'll be reading stuff.
Just
like
sort of.
that.
I'm just sort of picturing
What
how,
are you, what's your light reading?
I'm still reading this little bit by bit. I've been savoring it.
Dr. Tatiana's Sex Advice to All Creations.
Yeah. I haven't opened it
That's
in a while, actually, because I was trying to not read it too fast. So let's see. The last time I read, Dear Dr. Tatiana, I'm an Australian redback spider and I'm a failure. I said to my darling, take, eat. This is my body. And I vaulted into her jaws. But she spat me out and told me to get lost. Why did she spurn the ultimate sacrifice? Sincerely, wretched in the wilderness.
That's fascinating.
Yeah.
So this is what I've been reading.
Knock knock jokes for kids? Yeah.
Knock knock.
Who's there?
Ice cream soda.
Ice cream soda who?
Ice cream soda people can hear me.
Oh, that's great. I love it.
Oh my goodness, that sounds awesome.
Give me another one.
Knock knock.
Who's there?
Weed.
Weed who?
Weed better go home. It's time for dinner.
Boo.
Yeah, that's all winners.
I like the ice cream soda one. That was good.
Okay. I got one. I got. This is a good one.
Okay.
But you have to start.
Knock knock.
Who's there? Okay, let's just see if you knew any knock knock jokes.
Yeah. Yeah.
Oh the oldie and the goodie.
Oh my gosh.
Knock
Some
knock.
of these are really horrible. Who's
Who's
there?
there?
Orange.
Orange who?
Orange who?
Aren't you glad I answered the door?
Aww.
Knock knock.
Who's there?
Interrupting cow.
Interrupting cow.
Moo.
I can't do my usual knock knock joke because we're not in the same room.
Knock knock.
Who's there?
Who's that?
Orange.
Orange who?
Orange who?
Orange, you happy today?
That's not how that works. It's not the right joke.
Knock knock.
Who's there?
Who's there?
Orange.
Orange who?
Orange who?
Orange is a nice color.
That's true.
This is how this joke works.
Knock, knock.
Who's there?
Who's there?
Apple.
Apple who?
Apple who?
Aren't you glad I didn't say apple?
No, that's
But
not.
you did say apple.
That's you said apple. Okay. Knock knock.
I'm telling knock, knock jokes like my son.
Who's there?
Taken up.
What?
Taken up.
Taken up who?
Oh!
Ah.
Oh boy.
Knock knock.
Who's there?
Dwayne.
Dwayne who?
Dwayne the tub. I'm drowning.
Oh, mhm.
All Wiz Mike keeps posting in the chat room is the Senator Palpatine. No video. It's pretty funny. No.
You guys, what's a TWIP?
Huh?
What's a
A
TWIP?
twip? Oh, gosh, I have no idea. It sounds like a quip, but it's got a. Wait, what?
A TWIP is what a wabbit takes when he wides on a twain. That was my favorite joke growing up.
Okay. I have. Speaking of twips, I've got a big twip tomorrow morning with a lot of little rabbits.
Really? What you doing?
I'm doing. Apparently, the school decided that instead of taking multiple field trips throughout the year, it would make more sense to take 3 field trips in one day-long outing.
Oh. So
We're
all
gonna
the
be doing-
children will be garbage by the end of the day. That's a good idea.
Yeah, and as will be their entourage.
Yeah.
So I've got a full day of trying not to lose
How
3
many?
humans.
3.
I got,
Oh, that's not
I'm gonna
bad.
have. Yeah. Well, it's a whole day.
Where are you going?
I don't really know. We're going to the state capitol and the train museum, and then some
That
sort of
sounds like
IMAX.
fun.
And then some sort of
Okay.
what?
IMAX thing.
IMAX movie thing. I'm not completely clear on all of the details, to be
IMAX.
honest.
Okay.
I'm just going to show up where I'm supposed to
Get
be.
on the
at
bus.
there. No bus. I'm driving.
Well, then you have to know where you're going, sir.
Well, I get it. There's they give you a map, and I have a GPS thing in the
Okay.
car, and we'll
Mhm.
get them where they're supposed to be. The thing is, I have to end the day with the same number, and actually not just the number. I found out last
The
night.
same
Not just the number of
individuals.
kids,
Yeah.
the exact same individuals that I start the day with at the end of the day. So
Is one of them yours?
possibly, I don't know. Possibly, I have so many children now
Yeah.
that I'm not sure which
You're not
ones
sure
actually
which.
are and are not mine at this point. It's just
I'm pretty sure I went on a field trip when I was a kid before where one of my parents was a chaperone, but I was not in their group.
Oh no. They don't split you up like this.
I did think it was funny. I was like, oh, odd choice.
Yeah. And I kind of could get it in some situations. I have, with the exception of the youngest, perhaps, well behaved, very what do you call it? Cautious, conscientious.
I thought you were gonna say what do you call it? Children.
I have children. The youngest one is the one that's probably I would let her be in a different group just because she's gonna cause trouble. I know. No.
So
But-
which one is tomorrow?
I don't know. Tomorrow is Satya. This is 4th grade field trip.
Eldest, right?
Middleist.
Oh, middleist. Oh.
Yeah.
Yep. Okay. Yep. I remember now.
So we're gonna So then a couple other people's children who had to work in the morning,
Mhm.
and so I'm gonna get them there where they're supposed to be on time and make sure that they don't run off and join the circus during the day.
Mhm.
I guess.
Children's.
having said that,
Children's.
Try to make sure they pay attention. Also,
to
Children,
Whatever's
don't
happening.
join the circus. I did as a child. Don't be like your father.
yeah. Don't be telling knock knock jokes while the teacher's talking. All right. Don't be that chaperone.
Gosh. Knock knock.
Who's there?
Water.
What or who?
What are your favorite knock knock jokes? That one's not even good. Okay, I gotta go. I'm going now. Good night, everybody. Great show tonight. You both were, amazing. I think the minions in the chat room also were fantastic. They've stuck with us all the way through. That's really great.
All the way through.
Yeah. So say goodnight, Blair.
Good night, Blair. Say good night, Justin.
Good night, Justin.
Good night, Kiki.
Good night, Dr. Kiki. Is it just Kiki? Are we it's gotta be
I
Doctor.
just said good night.
Now we're gonna get this right.
Say good night, Kiki. Good night, Kiki. Good night, everyone. Thank you so much for joining us. Good night, Blair. Good night, Justin. Another great episode in the can. We hope you have a wonderful night's sleep or stay up and do things, whatever you're going to do.
Whatever
See you
strikes
next
your
week.
fancy.
Yeah. I'm going to
Whatever
have,
gets you through
I have a secret science mission this next week.
It's all about
Secret science mission. Dun, dun, dun. Secret. But I'll tell you about it next week.
This won't be a secret anymore.
Yeah, what I can tell you, I'll tell you.
Because we'll already know.
That's
We'll have no choice.
you.
All of you will know by next week.
Yep, pretty much. It's a secret until then. All right, you guys.
Good night, future Commander Kiki.
Good night.